it lighten up?
No. Did you flip it? No!
Today we'll be doing an experiment that involves sugar, baking soda, sea salt, distilled water, an open circuit, and a lamp. Don't mind me dancing in the background. Those moves are way too distracting. Calm yourself, young man.
So, we got this lamp and we open up the wires so the circuit is open, and we're leaving it to where the distilled water can be in here to complete the circuit, and we're going to add these three materials into the water to see if the light bulb will light up. Give us a thumbs up. Yay. Alright, so we got Homer filled with distilled water. We're going to pour and mist the pour. And now we're going to add some sugar into the bowl to see if the light will turn on. Nothing happened. We're gonna go to salt, sea salt. This is great. Great start. I think it's because the sugar is still in the bowl and the water is contaminated.
You think?
You're worth it.
It's still plugged.
I have salt. Yeah. Alright, now we're doing salt. And we're gonna do a lot of salt. From all point, I'm gonna.
Lit up.
So, this part I would explain in the voiceover because right now I don't know it.
So, the salt water, the salt dissolved in the water facilitates an optimal condition for the passage of current between the two electrodes. So basically, it's like they both like merge, and then it continues the circuit going to the other wire, and then like it creates a circle, goes up to the light bulb, flicks it on, and yeah. Homer mug. So this is the explanation as to why this is even happening in the first place. 1, salt water is a very good conductor. 2, sugar water is a poor conductor. That's pretty simple. And then the baking soda that was thrown in, if you didn't catch that, there was baking soda that was thrown in, and that is also a very good conductor. So it made the light bulb light up. Whoa. The copper metal in the wires are also very good conductors. Our rock salt is a poor conductor, which we didn't use in this case, but it's on the slideshow, so I'm reading it. And distilled water is a poor conductor, but we use that as the medium for the conductive stuff to travel through. The salt water, evidence for the salt water being a good conductor. The light bulb came on, there's a bright light. The sugar water, the bulb did not light at all. And then that was it. That's pretty much it for that one. Reasons for conductivity. The reason why salt water is a good conductor is because it has lots of charged sodium and chloride ions, and they are free to move around. But with sugar water, the sucrose and water molecules are neutral even though they are free to move around, so they cannot carry a charge.
So we have this bit of magnetic, like metal stuff in this little bowl container thing.
I'm pretty sure it's just metal.
And then we have magnet. So this is a demonstration of the magnetic fields that are floating around this. Will show how the field interacts with the metal pieces. I'm not sure if you can get that. There's a lot of things that have magnetic fields, like the Earth. The Earth has one huge magnetic field. And to draw it out, so it's sort of like this, but on both sides. And you loop around and keep everything cool.
Magnetism. Magnetic fields are produced by electric currents, which could be macroscopic currents in wires, or microscopic currents associated with electrons in atomic orbits. The magnetic field B is defined in terms of force on moving charge in the Lorentz force law. The interaction of magnetic field with charge leads to many practical applications. Magnetic field sources are essentially dipolar in nature, having a north and south magnetic pole. Magnetic field, it shows the image of a bar magnet and its north and south regions with the field drawn around it. A magnetic field is a region in which a magnetic force can be detected. The direction of the magnetic field at a given point can be defined as the direction that the north pole of a compass needle would point when placed at that point. The number of lines per unit area is proportional to the magnitude of the magnetic field. Magnetic field conventions for representing the direction of a magnetic field. In the plane of the page, it's an up arrow. Into the page is an X. Out of the page is a dot. And the north pole is painted red, always.